So what we're going to do today is we're going to look at rotational symmetry. And rotational symmetry means when you turn the shape, how many degrees do you need to go until it rotates onto itself, until basically it's the same exact thing. So normally with this, what we're going to want is we're going to want the center of rotation to be the center of the shape, or like roughly right here in this case. And then when you rotate this shape, I'm just going to use this and wait until it matches up with here. What you're going to do is you rotate it. 90 degrees isn't going to work. But if you go 180 degrees, then this piece right here becomes this piece, and this piece becomes this piece. So right here, this takes 180 degrees to rotate onto itself. Now we're going to look at some examples where we have some different numbers of degrees. So here we have three examples. We have an equilateral triangle, we have a square, and we have a regular pentagon. So one way to look at this is when you rotate these, and we were trying to figure out what's the minimum number of degrees to rotate it so that we end up with the same shape. So if you rotate this triangle, you can rotate it once, and this line's actually really helpful. It's a line right here because you can rotate it, go to here, and then you'd have a line that goes right there. And that would be like your original line if you rotate it one little turn. We'll figure out how much that turn is in a second. And then you can rotate it again, and you get up to there. And then you can rotate it one final time and go to there. So essentially what we're looking at is it takes 3 turns, all of the same size, to get it back to where it started. And at each one of these turns, 1, 2, and then 3, you end up with the exact same shape you started with. So the number of degrees it takes to get back to the original shape, the minimum number of degrees, is just this amount right here, or 1/3 of an entire circle. Well, a circle is 360, so we just divide that by 3, we get 120 degrees. And it turns out that this works exactly the same for this too. So you turn this 1/4 of a turn, and you end up here. You go again another 1/4 of a turn, you end here, and 1/4 of a turn there. This one, same idea. You do 360 divided by 4. Every 90 degrees, a square will rotate onto itself. And likewise with the pentagon, you do 360 divided by 5. Every 72 degrees, a pentagon will rotate onto itself. And of course, the one caveat with all this, of course, is that these are regular shapes. So all the sides and all the angles are the same. Equilateral triangle, a square, and a regular pentagon. Like this would not be the case. This 90-degree thing would not work out if this were a rectangle instead of a square. So we already have these first 3 that we just got from the last slide. We should also remember how we got these things. It was 360 divided by the number of sides. And then 360 divided by 4 here. And we had 360 divided by 5 here. So all you have to do for the next few here is just divide 360 by the number of sides. And the rule, which we're going to use this n-gon, which just kind of represents an algebraic rule of how to figure it out, is you do 360 divided by n, where n is the number of sides. That is the minimum number of degrees to rotate a regular polygon onto itself. 360 divided by n.